We've been working with polynomials, and now we're going to work with something called a polynomial function. So our ultimate goal is to evaluate polynomial functions, but we need to start with finding out what it is. So we'll begin with some definitions. I'd like to review, first of all, a little bit of function notation. When we start talking about functions, we're simply saying y equals f of x, and that means that there's a relationship between y and x. And if I plug in a value for x, I will get a y out, a y coordinate, or a y value. If we plot it, it's a y coordinate out. Okay, x comes in, y comes out, which of course can also be noted as f of x. An example, you've done this with linear functions, is we have some function f of x, also known as y, for your purposes, which is negative 2x plus 6. And we want to find f of negative 3. Well, all we're going to do is look at the function we've been given, and everywhere we see an x, we're going to put in negative 3. So f of negative 3 is negative 2 times negative 3 plus 6, which is a positive 6 plus 6, and the last time I checked that was 12. Now, we can do this for things that other than linear functions, more interesting functions with powers other than 1. So let's look at a more general case. I'll throw a definition down here that we'll then do some nice practical examples with. We're going to look at a polynomial function of degree n. Now, this is just going to be a polynomial with one variable, and we're going to say the function, instead of writing f of x, we'll write p of x, and this will remind us that we're working with a polynomial. And it's going to be related to x by this general equation, a with a subscript n times x to the n. So we've got a coefficient that's associated with x raised to a power n. This subscript just tells us that it matches this coefficient, goes with it, plus a n minus 1 times x to the n minus 1. What we're doing is we're writing this in decreasing order for the powers. And it goes on, and we run out of page, so we wrap around until we have a1x. X is to the first power, so we put the subscript 1 on the a just to identify the two, plus a naught, or a with the subscript 0, and this is a constant term. And the restrictions we'll place on this are that we have real a's, so this a sub n minus 1, and so on, all the way down to our constant term, our real, and that this first coefficient, a sub n, is not equal to 0, and that n is a whole number. So, what does all this mean? At the end of the day, I have this relationship between y and x, p of x, in our function notation. Polynomial in one variable. one letter. The variables have numerical coefficients. They might be 1, might be 0, in which case you don't see that particular power showing up. And we're working with what you might come to think of as kind of normal looking. So I'll put it in quotes because there's really no such thing as abnormal. But normal powers, the things you're used to looking at, like you've been using to date.